Hello everyone. We have a question which says that a smooth ring R over here of mass m kg, the mass of the ring is m kg, so definitely multiply it by 10 to get the weight, because weight is equals to mg, so m multiplied by 10 and 10m is the weight of the ring in Newton. Ring R of mass m kg is threaded on a light inextensible string ARB. So basically it is a ring. So we have a string ARB and this string is passing in between the ring. So basically this is simply just one string, not two strings. The end of the strings are attached to fixed point A and B. So basically this is just a single string and the two ends of the string are attached to point A and B, and A is vertically above B, and we can see that yes, A is exactly vertically above B. The string is taut and angle ARB is 90, and this string is taut, that means it is not slacked and it is making an angle of 90 degree over here according to the statement. The angle between the part AR, where is AR? This is the AR. The angle between the part AR of the string and the vertical is 45. That means over here the angle is 45 degree with the vertical and this part of the string, but because this is 90 degree and we know the sum of the triangle is 180 degree, if this is 45, this is 90, that means this is also 45. And for example, if we draw a horizontal line over here, when we say that we draw a horizontal line over here, that means this would be 90, and when this is 90, this is 45, just add them up, subtract from 180, this will also be 45 degree. According to the question, the ring is held in equilibrium, so the condition is very clear. In equilibrium condition, in this position by a force of magnitude 2.5 Newton, and we have another force 2.5 Newton, and this force is being applied to the ring, acting on the ring. That means this force of magnitude 2.5 Newton acting on the ring in the direction of BR. So basically this BR is the direction and the force is also applied in the direction of BR, which is a 2.5 Newton force. Calculate the tension in the string and the mass of the ring. So basically we have to find two things: the tension in the string, and this is simply a single string, and we have to find the mass of the ring. So before that we have to understand the concept. Whenever we have a ring, so don't think that the tension in this part would be different and the tension in this part would be different. No, because it is a ring and a single string is passing in between the ring, so the tension in this part and in this part would be same. So if we split them up into components, horizontal and vertical component, because the condition is an equilibrium, so we could easily get the value, the required result, which is to calculate the tension and the mass. For that, we first of all we have to understand what the components are, whether it is a horizontal or vertical, because I have seen that most of the students have a misconception that the horizontal component is always a cos component. No, it is not like that. If this is an angle theta which is with the x-axis, then the side next to that would be a cos component of that particular force, and the opposite would be a sine component of that particular force. And if the angle is with the vertical, then the side next to that would be a cos component of that particular force, and the opposite would be sine component of that particular force. That means the horizontal is not always a cos component. It depends upon where the angle is. Is it with the x-axis or with the y-axis? Based on that, we could easily get the cos component and the sine component. So basically our target is to get the tension in the string and the mass, and the condition is an equilibrium. So splitting up the diagram into horizontal and vertical component, so we have done it over here. So let us just understand what we have done. As I have mentioned below, if we draw a horizontal line over here, and that horizontal line would make a 90 degree over here, and this 90 plus 45 is 135, when subtracted from 180 would again give a 45 degree, which is over here. And because it is again 90 degree over here, because this is 90 and then that is also 90, so 45 plus 90 is again 135, and when we subtract it from 180, again this would become 45 degrees. So basically this 2.5 Newton force is making an angle of 45 degree with the x-axis. So the horizontal component would be 2.5 cos 45 and vertical would be 2.5 sin 45. And if we look at this, because the tension in the string is the same whether it is over here or over here, so I have written the same T over here and T over here because the tension is same, because it is a single string. So the horizontal component over here, for example, if we talk about this particular 45, and definitely then this would be cos component, but if we talk about this 45, then this side would be cos. It is totally up to us from where we have to work through. For example, if we consider this 45 degree as an angle, then this side would be cos component and this would be T cos 45 and the vertical would be T sin 45. Similarly, because it is 90, if that is 45, this is also 45. Again, due to this 45 degree, this would be a cos component T cos 45 and a vertical T sin 45 pointing downward. So based on the equilibrium condition, we have to work out with the horizontal forces as well as the vertical forces. And if we look at the diagram, we have horizontal forces as T cos 45 and T cos 45 to the left and 2.5 cos 45 to the right. Because of equilibrium, the opposite sides are equal, so the sum of these two would be equal to 2.5 cos 45, and we have done the same, that 2 cos 45 plus T cos 45 plus T cos 45, which is over here, would be equal to 2.5 cos 45. So T plus T is 2T cos 45 is equal to this. We can see both sides have cos 45, we have cancelled them, and 2T is equals to 2.5 and T is equals to 2.5 divided by 2, and finally the value of T is 1.25, which is the tension in the string. Now we have to find the mass of the ring as well. For that we would consider the vertical forces. So if you just look at the diagram and the component that we have written, the vertical component that we have written, we have T sin 45 upward, 2.5 sin 45 upward, and T sin 45 downward and 10m downward. According to the equilibrium, the sum of these two would be equal to the sum of these two. So 10m plus T sin 45 would be equal to T sin 45 plus 2.5 sin 45. As we can see, we have a T sin 45 both positive on both sides of equal sign. We could cancel them, or if we move that on the other side, it would be negative. Again, it would be cancelled out. So we are left with 10m is equal to 2.5 sin 45. So m is equals to 2.5 sin 45 divided by this 10, and finally we have the mass of the ring in terms of kilogram, which is 0.177.